got this 120 volt bulb I pulled out of my bathroom here, and you can see that when I adjust the spark gap distance just right, it has some pretty cool effects here. This is all dependent upon the spark gap length, which is in this arrangement only because the spark gap length is going to determine how much voltage this capacitor is charging to. So that's, I don't know, that's pretty cool how that works. Alright, now I've got a second aluminum capacitor here introduced across the output of the secondary on the flyback. So it's more or less a super dirty representation of the basic hairpin circuit. Off of each end of the secondary, I've got a capacitor, and they more or less join together in series once you add the load or shunt across the bars, which I don't have here. The bars in this case, conductors across this cable here, which goes to this light. And it's basically more or less the same thing as using one capacitor, but now I've just made sure I've got dielectric isolation totally between the secondary and the load here. Here I'm basically using the same deal, this air capacitor, which is in series with the spark gap. So you see I've just basically got my secondary coming to these two little brushes from a drill that's forming my spark gap there, and in series with that is this right here. So even if I close that gap, I'm still going to have the very slight gap in this capacitor here. One of them I screwed up. I'm not sure how I did that, so these two I've only got hooked up, but the arc will dance around a lot between those plates. I just pulled this out the damn refrigerator. It's a 40 watt 120 volt bulb, but it will light, and if I get the arc distance just right, then you can sort of see it teetering back and forth between, you know, wanting to arc across the little electrodes in there and then wanting to power that little resistor in there, more or less. So I'm gonna cut it on. So before, I was just pulsing into this bent copper wire through basically just a small spark gap. In this setup, I'm using the two capacitors. Now, first of all, none of these are matched. There's no resonance going on or anything like that. The values are way off, but I'm just basically charging some fairly high voltage capacitors from this flyback output that is switching on and off with this PWM. I guess normally the big fuss is supposed to be that since you've got these two capacitors here more or less separating where your loads are connected, they shouldn't be seeing any current or something along those lines. And you can see clearly something going on there. I mean, it looks like I'm shorting out a little bit of current that's going across through the actual bar here. You can sort of see it on the other side too. Let me get over here. We just drag it so you can see it. So I've just got these two copper strips down here just to simulate the bars, and it's not shorted at the end. I'm going to cut it on here. And you know, before I actually attach the load, which puts the two capacitors in series, then I'm just pulling this high frequency arc there where the caps don't get to charge and discharge. And then when I introduce this resistive load, putting the caps in series, you'll see they start discharging, you know, semi-furiously, giving that little gap there. And it lights the bulb up. So it's nothing crazy. I mean, right now we're pulling, you know, all this power. It's like over 60 watts because of that arc we're pulling. And then add the capacitor, light the light up, and then now we're pulling less watts, a little over 40, with the light going, because those caps are now able to discharge and the frequency into the load has dropped. So whereas before it was a fairly high frequency, high current, now it's a much lower frequency, high current in moments of time, I suppose you could say. But if I get that gap going, if I get this gap going much further, then maybe I can get it to arc. It did there for a second. I just need a little more distance, yeah. It looks pretty cool when it does both, if you can get it just right, so it'll dance around between both. It's pretty cool. I don't really have a sophisticated spark gap here right now. There you go. To me, that's a pretty cool effect. That's a pretty cool effect. But it is still pretty cool that if you get the distance right, then can light a bulb up pretty good. Now, these capacitors, just to note, these capacitors, I just rolled these suckers up. I'm guessing they're around 5 nanofarad or so. The very first one I rolled, the biggest one, that was about 20 nanofarad. That did not take long for me to arc through. Every single one I've rolled since, I haven't had a whole lot of luck keeping it from breaking down on the inside. They do eventually arc over and start poking through, which is usually at the point where I've got the lead attached. You can feel the amount of current that's going in there, and it is impressive, but at the same time, I'm kind of looking at it like, well, shit, have you ever felt the heat going through an arc of plasma? Like a nice purple arc of plasma. So that's to say, I mean, you know, I've held bulbs like this up to low power Slayer exciters, watching the little arc jump across in there, a little maybe purple orangish arc, and that sucker gets so hot you can't hold it within no time. So I mean, if we're talking just sheer heat that we could generate from very high voltage, then you know, plasma does it. I'm gonna try different bulbs here. So saw this one, and let's see what this one does. A little vintage type deal. And my gap is way too far. So that was not too bad. Just with a random arc length. I tell you what though, this setup sucks a lot of balls too. People shouldn't be doing setups like this. Sort of dangerous. But I'm not dealing with a neon transformer here. So I don't think of, yeah, I showed this one earlier. Let's put this one back on. See what this little bastard does. Just been trying different frequencies, duty cycles. So yeah, I'd really like to have a 12 volt automotive bulb. Maybe I need to go pull one out of my freaking car. As far as calling it cold electricity, I guess you could say the way it's being derived is the interesting part. What I would like to do is get a much bigger setup built, which I might try doing with some aluminum rods I have, to more or less see if I can get legit bars going that might be big enough to where I might actually be able to get some resonance going with the right capacitors, if I can get my hands on them, to see maybe some wavelengths, actually see the wavelengths. And you know, as far as touching it, I'm not going to touch that. I mean, it's going to shock me. I already know that. You know, if I shorted the bar out, if I shorted that out, then I can touch it all day long, assuming those are still there and connected. It's not going to shock me, and I can see that. I forgot to try some fluorescence. All I've got is really old ones that about kicked it. So I've got this one here. Got it clipped over on one side of the this one little bar here, one strip, and I'm just gonna touch it to the other one. So I'm gonna cut it on. There goes my little thin purple arc, and goes the white. It lights up just barely. Nothing crazy, and yeah, well, it's got high voltage there. Light that up. So I mean, now once that gas ignites, now you've got a clear path for that cap to really discharge through that arc there, through that small gap. Now you're letting the caps discharge. See, the voltage is actually too high. It starts arcing in there, and it burns it out. And you know, likewise, it's kind of cool. Like if I get these close enough, if I just put both sides on there, really start pulling a little arc. But once it's dead shorted, the electrodes in there on that one side, it's just burning out. sucker's burning out hardcore. Alright, I've got sort of a big saltwater cap on there now, and I'm gonna I've got this bulb hooked up to it, so bulb still light, it's more or less the same deal, but very slight adjustment in the spark gap makes a huge difference at some point. So I'm going to show that. So with that little, with that tiny gap there, with that tiny gap you see, just varying the air capacitor here a little bit, the way the spark dances around in there, really changes the intensity. You see, once it starts to get to a point I can kind of hear it because I'm running my power supply off the same thing I got some speakers plugged into, and when I get to the point where the bulb is the brightest, I can hear that sort of that white static noise the most, and it sort of sounds to me like the arc has found a way to dance around as best as it would like. Sort of like the way people are trying to quench their spark gaps and whatnot, but it sort of finds a spot with this little air cap here. Again, here with this little setup with the output basically just going to this little copper bar here and this little grain of wheat bulb, which how it is, you know, you basically just got this capacitor in series with the bar going back to the other side of the high voltage output. So it's just high voltage output going through all the way, capacitor, bar, and then also on the output we've got the spark gap with the air capacitor being part of the spark gap, with both sort of I'm using both to adjust the distance. And it will light a little bit, you know, nothing special going on, no resonance, but it will glow, showing that the bulb is pulling some amount of current across this bar here. There you go. Glowing a little bit. Seems to almost like just the air capacitor by itself. Which, let me see if I can adjust that. So, interestingly, with the way this air capacitor is, it's sort of serving as a capacitor and spark gap at the same time, but you can see there's a certain type of way that it likes the best. So right around here, whatever little arcs it's able to get down in there, which isn't so much different than something like right there, it kind of likes. Kind of hard to see. You can see it does light, I would imagine, with different variables, get it to light much brighter. But again, the only thing is, you know, you could do the same thing by taking this little high voltage stun module, which is going to have a high voltage capacitor output. It's going to pop. And you could do the same thing, arc to this little bar here, and it will also light that up.